Hello and welcome to Engineering Simple. In this video, I will give some kind of tips on how to solve complex equations. So any equation, the way you would approach solving it is you can look at the equation and see how, you can change it from looking complicated into something that's simple to solve basically. So if we look here, we can see that we have e to the power of 2x minus 2 times e to the power of x plus 1. So this is not easy to solve. But one way I can notice that I have e here, then I have x, and I have x here. What if I rewrite this as x squared, which is the same thing basically, then just rewrite the other ones, plus 1 is equal to 0. So now what if I let big X equal to e to the power of x? So then I can rewrite this equation, basically replace e to the power of x with uppercase X. So now I have x squared minus 2x plus 1 is equal to 0. So now I have a quadratic equation, which is kind of familiar and easier to solve. So from here, if you watch previous videos on remarkable identities, this would be basically x minus 1 squared equal to 0. So then x minus 1 squared equal to 0 means x minus 1 basically is equal to 0, which means, so basically you will just move minus 1 to the other side by changing its sign. So x equal 0 plus 1. Like I said, if you move minus 1 to the other side, you just change the sign. That's what I did here, which is basically equal to 1. So I'll go back to so big X is equal to 1. And what is big X? It's e to the power of x basically. So, and we know e to the power of 0 is equal to 1. That means x is equal to 0. So let me go back and to the original equation and replace x with 0. So e to the power of 2 times 0 minus 2 times e to the power of x, replace that with 0, plus 1. E to the power of 2 times 0 is just e to the power of 0 minus 2. E to the power of 0 is just 1, so that times 1 plus 1. E to the power of 0 is just 1 minus 2 times 1 is just 2 plus 1. So 1 plus 1 is 2 minus 2 is 0. Check. So the solution to this equation, basically x is equal to 0. So the key here is I changed this equation from being exponential into something that's quadratic, that's familiar. So let's look at another example. In this case, I have 2 to the power of 2 times x minus 4. Again, this cannot be solved directly. It's kind of complicated. But notice again, I have a pattern here. So I have 2x, 2 to the power of x squared, which is the same as 2 to the power of 2 times x, basically, minus 4, which is just 2 to the power of 2, is equal to 0. So now let's let 2 to the power of x equal to large X, basically. Then I can transform this equation to x squared minus 2 squared is equal to 0. And again, I would recommend going back to the video on remarkable identities. This here would be factored as x minus 2 times x plus 2 is equals 0. The product of two terms equal to 0 means that one of them is equal to 0 or both. So let's set x minus 2 equal to 0 or x plus 2 equal to 0. Because if one of them happens to be 0, the entire thing is 0. So that means big X equal to, again, I will move this to the other side by changing its sign, or X equal, so I will move this to the other side, changing its sign. So, and what is large X? So large X is equal to 2, or large X is equal to negative 2. Large X is 2 to the power of small x, basically. So if I notice from here, so 2 is the same as 2 to the power of 1. That means small x equal to 1. This one means large X is equal to negative 2, and replace large X with 2 to the power of X. We know this here, this 2 to the power of X will always be positive because 2 to the power of whatever is always positive. So we know this will not be a solution. So I'll cross that out. So I obtained X is equal to 1. So now let me go back and check. So whenever I see X, I'm going to replace it with 1. 2 times 1 minus 4. 2 to the power of 2 times 1 is just 2 minus 4. 2 to the power of 2 is 4 minus 4 is equal to 0. So again, the key here, I made an observation that I can change this into a quadratic equation basically by, instead of x being as an exponent, I change it into a quadratic equation. So that was it for this video. Thank you.